Imagine staring up at the night sky filled with twinkling stars. Most of them seem calm, eternal, almost peaceful. But what if I told you that some of those stars aren't just distant lights? They are bizarre, chaotic, and in some cases, absolutely terrifying. These are the strangest stars in the universe. Some can rip atoms apart with their magnetic fields, while others are so massive they could swallow entire solar systems. And a few are just mysteries we still can't explain. In this journey across space, we're not just talking about big, bright stars. We're diving into cosmic oddities, stars that pulse, explode, flicker, or hide strange secrets deep within their cores. These stars challenge our understanding of physics, stretch the limits of what should be possible, and even raise the question, could something unnatural be behind some of these cosmic mysteries? From stars that survived their own deaths to those that shine like diamonds, and even stars that might be powered by alien megastructures, this is the ultimate guide to the weirdest stellar phenomena out there. So buckle up, space explorers, because once you see how truly strange the universe can be, you'll never look at the stars the same way again. Let's begin with a star that shouldn't exist, a star that died, and came back, no one. The zombie star, surviving a supernova. When a white dwarf explodes as a supernova, it's usually the end. The explosion rips the star apart, releasing a burst of energy so powerful it can briefly outshine an entire galaxy. But in rare cases, something unbelievable happens. The star survives. These are called zombie stars. They are white dwarfs that went supernova but somehow didn't completely die. Instead, they reignite, reform, and keep shining. It's like watching someone walk away from a car that just exploded, impossible but real. One such case is IPTF-14HLS, a supernova that just wouldn't stop exploding. Most supernovae last a few weeks. This one? It kept going for more than 600 days, brightening and dimming multiple times like it couldn't decide whether to live or die. Scientists believe that IPTF-14HLS may be a type of pulsational pair instability supernova, a process where the star undergoes several violent eruptions without fully destroying itself. It's as if the star was trying to die but kept getting pulled back to life. We still don't fully understand these zombie stars, but their very existence shows us that the life cycle of stars can be far more complex than the simple birth-to-death story we once believed. No. 2. Thorne-Żytkow objects, a star inside a star. Now imagine a star with another star hidden inside it. Sounds like science fiction? Welcome to the world of Thorne-Żytkow objects, or TZOs, perhaps the strangest hybrid stars ever proposed. Here's how it happens. A neutron star, the super-dense core left behind after a supernova, collides with a red supergiant. But instead of destroying each other, the neutron star sinks into the red giant's core. What you get is a neutron star at the center of a bloated, fiery outer shell. This fusion of stellar remnants creates a bizarre, unstable object with extremely unusual chemistry. In fact, astronomers suspect we may have already found one, a star called HV 2112 in the Small Magellanic Cloud. Its chemical signature doesn't match any known type of star. That might be the smoking gun. These objects are theoretical and incredibly rare, but if confirmed, they'd reveal a new phase of stellar evolution. One where stars don't just live and die, but merge and mutate in ways we've never imagined. Thorne-Żytkow objects remind us that space isn't just violent, it's weird. No. 3. Magnetars, the universe's most dangerous stars. If stars had superpowers, magnetars would be the villains. These are neutron stars, already insanely dense, that took things to the next level by developing magnetic fields a trillion times stronger than Earth's. One magnetar in our galaxy, SGR 1806-20, released more energy in a fraction of a second than the Sun emits in 100,000 years. Their magnetic fields are so strong, they can disrupt electronics from thousands of miles away. If a magnetar were within 1,000 kilometers of Earth, it would erase your credit cards, distort atoms in your body, and probably kill you before you even knew what hit you. How do they form? After a massive star explodes and collapses into a neutron star, sometimes the resulting magnetic field becomes twisted and amplified. That's when it turns into a magnetar. They're rare, only about 30 are known. And they don't last long in cosmic terms, maybe 10,000 years. But while they're active, they're terrifying. Some scientists have even suggested that sudden gamma-ray bursts from distant magnetars could cause mass extinctions on Earth, if we were unlucky enough to be in the path. So if you're making a list of stars you don't want near your planet, magnetars are at the top.